Sabrina Sanchez. I interned at Stanford University. My mentor was Dr. Daniel Fernandez, and I got to work on protein 3610, which was the original project, and then we shifted to 0003, which is just a different protein. Get started. Okay, so a little bit of background is you need to know what proteins are, right? So proteins are made from amino acids. There are 20 amino acids, and our body can only create some types of proteins, not all. Proteins help our body grow, build and repair muscle, repair cells, and make hormones and create enzymes. Okay. So what is the big picture? The big picture of our project, so this is what each protein could lead to. The original protein could lead to cancer treatment, development of sustainable energy sources, fight against antibiotic resistance, and diabetes treatment. And then the protein we shifted to, which was 0003, can lead to a therapeutic target for fungal asthma. So what does this mean? What is our major goal? Our major goal was to make enough protein to be able to crystallize it, because after crystallizing, we would then be able to send these crystals to another facility, also known as SLAC. They would then give us the structure of the protein, and we would be able to break that down. What we're looking for is difference in the structure, because differences in the structure can lead to a better understanding of how this protein could help us. So materials and methods, just to jump into the steps right away, there was a lot of stocks and things we had to prepare before, but we can jump right in. The first step was transforming cells. So what we did was we transformed E. coli cells, and what we were trying to do was practically just make colonies. These are the same colonies that we would then use in our second step, which is pre-culturing. We would use one colony in our pre-culture. After pre-culturing, we would then move to step number 3, which is culturing. After pre-culturing, we would then move to step number 3, which is culturing. Put our pre-cultures in 1 liter of LB and leave it shaking for approximately 3 hours at 37 degrees. And then after those 3 hours, we have to check every 30 minutes in the nanodrop, because the cells start doubling and we want the absorbency to be from 0.6 to 0.8 to be higher than that. So we had to kind of rigorously check every 30 minutes or less sometimes. We would then, when they're ready, we leave them shaking overnight. And then we would be able to jump into step 4, which would be the next day, which we call spin down. We equally weighed what we left shaking overnight and put it into the centrifuge machine here. The first time we put it into the centrifuge, what we wanted to collect was the cells. We would then prepare the cells in lysis buffer and like other liquids that help these cells release the protein. We just had to make sure the cells was very much liquid form before we put it into the centrifuge again. We're taking it out of the centrifuge. What we wanted to keep this time is the liquid instead of the cells that stick into the wall of the centrifuge tube, because the liquid is what actually has the protein, because the cells have released the protein into the liquid by then. We would then pour that liquid into the column. This column has nickel resin. The protein would be left in between the resin, and we would collect fractions of the protein in different concentrations of imidazole. But we knew that our protein succeeded best in concentration 200 and 250. So that was like our main goal in collecting those fractions. We would then be able to move on to step 5, which was purification. We would then purify the protein by putting it into the FPLC machine. Overall, the FPLC machine is what would tell us if we had enough protein, which for both projects, unfortunately, we didn't. So we weren't able to move on to step 6, which was crystallizing, but we were still able to see the process of crystallizing because we got to use a different protein just so that we could see that process. Okay, so overall results. We didn't have enough protein to crystallize, but we were still able to see crystallization through a different protein, lysozyme. And then in conclusion, we know that we need more protein if we get there. As my mentor stated, this can take up to a few years to be able to get those results, but if we had time, we could probably get there. I'm pretty confident with the work we did. Time is an important factor, which was very limited. If we had more time, I think I would have loved to see us get there, but unfortunately we didn't. The most important key skill was that I understand the process of protein expression, purification, and crystallization, which was the goal. So I'm very happy with all the work we did in this project. I think a challenge was having to repeat the experiment so many times, but I also think I learned so much from having to repeat it so many times. So I think the major successes was seeing crystallization under a microscope. Personally, it was the most beautiful part of this whole experiment, even if it wasn't with the protein we wanted to see it with. I also got to gain a lot of confidence in the lab. I think I love the lab. I thrive in the lab. So it was very nice to work along people who also obviously love and cherish being in the lab. I think it was very fun and great to be with other people who also love the lab. I got to understand lab calculations. My mentor was awesome, very patient, and always reworded himself if I didn't understand it the first time. So it was very nice to hear and be able to understand everything that I'm writing down. Personal insight. I definitely think that I might want to get my PhD after doing this. So, I mean, that's very nice. Research is challenging, but it's beautiful and it's fun. So it's something I definitely look forward to. Acknowledgements. I had an awesome mentor, Dr. Daniel Fernandez. I think I learned a lot from him. He seems to love what he does, and it's very beautiful to see. As well as Dr. Olivia Patelli. She was very supportive and helpful all along. And my colleague, she was another intern that I got to work with. Her name is Rasha, and it was beautiful to be able to see this with our own eyes. I think we relied on each other a lot, and when one of us didn't have questions, the other one did, so that was nice. Sophia and Marissa, thank you. I think because of you guys, I've gotten this far. The support has been immense, so thank you so much.